Wireless pyodynamic detector ZBL-P8000 are designed to test the integrity of concrete pile and identify the location and range of pile defects according to reflected wave transmission rules. The instrument consists of a host, Huawei tablet, hammers, and other accessories, and a power management circuit, etc. are all enclosed into the dynamic detector host. The hexagonal metal part at the bottom of the host is ICP acceleration sensor. This red button is the power switch. Charging indicator is just above the power switch. It is red when charging and it turns green when host's electricity is full. Above the charging indicator is working indicator. If working indicator is red, it means the host is in low power condition. And if the working indicator is green, the host can work normally. And if the working indicator flash red and green, it means the host is pairing with the pad. Open the protective cover, you can see the charging part. You'd better cover it when not in use so as to protect the host. Our specialized software is installed in the pad with Android system, and the software can transfer, analyze, and store the test data received by the host. Hammer. We use hammer to strike the top of pile to produce stress wave. We provide you several hammerheads of different weights and materials. The stress wave frequency caused by the striking of aluminum alloy hammer is pretty high, which is suitable to judge the shallow floor of a pile, while the stress wave frequency caused by the striking of nylon hammer is rather low, which is suitable to judge the pile's deep defects. Besides, you can purchase another force stick as striking device if the pile you test is too long and big. Instructions. We should do some preparations before testing. Clean the pile head. The coupling point of the sensor and the striking point of the hammer must be clean, flat, and hard, so it is necessary to do something with the pile head before testing. Clean the floating cement and other sundries on the pile head. Coupling agent should be thin but with great viscosity, and this viscosity should not be affected by water. We use butter here. Press power switch to start up the instrument. Turn on the pad and find the application P8000 wireless pyodynamic detector on desktop, and then click and open it. Click the Wi-Fi icon on the upper right corner can enter the network setting interface. Manually select the network to connect and input right password. After a successful connection, the Wi-Fi icon stopped flashing. Battery level is displayed. Parameter settings. Click Pile parameter button. You can set a project name, pile number, pile length, wave speed, pile shape, pile diameter, and pile type according to the project's real information. Click Sampling parameter button. Sampling interval refers to the time interval between every two sampling signals. You can select one of the 9 intervals. The value can be set or not, but pile length and velocity must be set before sampling so that it will automatically calculate the sampling interval value. Sampling length refers to the quantity of signal sampling points, and you have two choices, 1024 and 2048. Generally, 1024 can meet your requirements. Blue number refers to the total number waveform that every channel to select. There are multi-options. Minimum is 1, maximum is 12. Gain refers to the amplification factor of signal which is received by sensor. Generally, gain value should be adjusted according to pile length, condition for pile head surface, and striking equipment, hammer, etc. When the signal is weak, you can turn up the gain value. When the signal is strong, you'd better turn down the gain value. Trigger level refers to the signal level collected when starting the instrument. There are 3 levels, low, medium, and high. The higher trigger level is, the stronger the signal is required. Generally, you'd better choose low level when the gain value is less than 8, and you'd better choose medium or high level when the gain value is more than 8. Sampling method. There are 2 methods, single collection and continuous collection. Single collection means according to the parameter setting, only one waveform can be collected once. Continuous collection means according to the same parameter set, continuous multiple waveform can be collected until the acquisition be stopped. Overlap. You can choose a number between 1 and 6. If the number is bigger than 1, it is an overlapping sample, which means all the samples collected in the same channel will be added together and then averaged. Acceptance mode. 3 modes are accepted: automatic, manual, and all. In automatic mode, if the strike is too heavy or light, the dynamic detector will automatically abandon the signal while show corresponding message. Only when the percussion is moderate will the collected signal to be a useful one. In manual mode, if the strike is too heavy or light, dynamic detector will give appropriate message and ask whether to return the signal or not. When the all mode be selected, if the strike is too heavy or light, dynamic detector will be given the corresponding message and keep the signal. Equipment parameter shows the basic information of the instrument. Click Display Parameter and it switches to Display Parameter interface. Width refers to the width of a signal channel waveform. The bigger the bandwidth is, the wider the waveform is, with the default as 1. Axis can be length or time, and generally we choose length. Screen refers to the amount of waveform display in every screen. Options are 1, 2, 3, or 4. The number in every panel cannot be bigger than the sampling number. Set restore default parameter. You can choose to recover some parameters. You can set the information of operator from operator interface. After setting all parameters, return to the sampling interface. Pile test. You can choose 1 to 4 testing points according to how big the pile is. Defects or cracks are not allowed at the installation points of the sensor or somewhere near it. When the hammering point is at the center of the pile head, the distance between the installation point of the sensor and the center of the pile shall be 2/3 of the pile radius. When the hammering point is not at the center of the pile head, The distance between the installation point of the sensor and the striking point shall be more than a half of the radius. Take a 1 meter diameter pile as an example. We choose 3 testing points and locate a hammering point at the center of the pile. Sensor and the testing point should be completely struck together by butter or petrolatum, and ensure the sensor is vertical to the top of the pile. Click Sample button. Place the sensor at the first testing point and strike the center of the pile 3 times with the hammer. Click Stop button. Then place the sensor at the second testing point and strike the center of the pile 3 times with the hammer. Click Stop button. At last, place the sensor at the third testing point and strike the center of the pile 3 times with the hammer again. Click Stop button after you have finished the sampling work. Click Save button. The default name is the pile name set before the test, and you can save directly if you don't need to change it. Then we finish the test of the pile. If you need to continue to test other piles, click button New Piles in the pile information area on the right side. Then you can continue to detect next pile. After you have tested all the piles, data can be transferred to your computer for analysis and report generation. Click File button and select FTP Upload. Enter username and password, and click Start button. IP address of data accessed by PC will be generated. Input such IP address in the computer address bar according to below suggestive address. A dialog box will pop up asking you to enter the same username and password. Then you can find out all data files. Select data files and copy them into PC. Data analysis. Click and open Analytics software of testing pile by reflected wave. Click File button and find the file you want to analyze and open it. The middle part of the software interface is wave diagram area. Pile list of this project lines on the left side of wave diagram area. Pile information area and waveform processing area line above wave diagram area. You can further improve or modify the pile's information in pile information area on the left side. Look at waveform processing area on the right side. You should choose integral as we use ICP acceleration sensor. Wavelet factor can optimize the signal through wavelet analysis method. And the bigger the wavelet factor is, the smoother the signal diagram is. Generally, wavelet factor should be set between 1 and 3, but you can set a bigger wavelet factor if the pile you detect is pretty long. If the wavelet factor you set is too big, some useful signals will be filtered out, causing misjudgment. Smoothing points refers to how smooth the signal diagram is. The bigger the smoothing points is, the smoother the signal diagram is. Smoothing points range between 3 and 512, and generally it is set at 10. Amplification type, you have 3 kinds of choice: exponent, linear, and full scale. Usually, we select exponent. Its characteristic is the signal will be magnified on exponent. As for amplification factor, you can choose according to your need. Amplification from means the starting place to magnify. Filtering mode has 4 types: all pass, low pass, high pass, and band pass. Low pass can filter out the signals higher than a certain cutoff frequency. High pass can filter out the signals lower than a certain cutoff frequency. Bandpass can filter out the signals higher than a certain cutoff frequency and at the same time lower than a certain cutoff frequency. Usually, we choose low pass more. Waveform rotation. Sometimes after the integral processing of the signal, the end of waveform will be upturned. Then the waveform needs to rotate, making the end back to the position of the baseline. The percentage of the rotation is relative to the amplitude of direct wave. Positive number indicate clockwise rotation, while negative number indicate counterclockwise rotation. Default means user set all parameters as the recent one. Parameter recovery means user set the parameters value as the default one. Tension and compression ratio means users can compress and stretch the waveform. Now we will analyze several typical waveforms. Good pile waveform. As the waveform from a good pile, wave crest will appear separately at pile head and pile toe. And if pile body hasn't defects, the waveform diagram between the pile head and pile toe will be a straight line. Double-clicking on the waveform area stretches the waveform vertically. Expanded pile waveform. This is a 45-meter pile, and the first wave crest is the pile head, and you can find another wave crest at the pile toe, but a significant wave trough appears at about 5 meters. This is a typical waveform of expanded pile. Reduced pile waveform. Except for the wave crest at pile head and pile toe, another wave crest appears, caused by secondary reflection of a reduced pile. This is the typical reduced pile waveform. Broken pile waveform. In this waveform, the first wave crest is pile head. This pile is 10 meters, so the pile toe wave crest is supposed to appear at 10 meters, but it doesn't. You can see a wave crest appears at about 3.5 meters, and you can also find other wave crests every 3.5 meters. This is the typical waveform characteristic of a broken pile. Create a report. When you create a report, choose the IT files on the pile list area, click Tools button on the menu bar, click Export Word File button, and then create a report and open it. Now, the instructions of wireless pile dynamic detector ZBL-P8000 has ended. Thanks for your watching.